We'll be reviewing for exam 1, and it'll look just like this review guide. So first step for the first problem is we'll distribute the -3. We'll get -3x plus 3 is equal to 3x plus 2. And we want to get all the x's on the left-hand side. Then we'll get all the constants or the numbers on the other side. And then you don't want -6x, we want 1x. So let's divide by -6. And we just get x is equal to 1/6. Second problem is going to be similar, except we have fractions. And in class, we talked about the way you get rid of fractions is by multiplying by the least common denominator. So the smallest number that you could divide by 2 and 3 would be 6. So if our least common denominator is 6, what we're going to do is multiply each term by that. So 6 times 1/2 x plus 6 times 2 is equal to 6 times 1/3. Now I like drawing these arches because that helps me make sure that I'm multiplying 6 times each term. 6 times 1/2 is 3x plus 12 is equal to 2. And again, getting the x by itself, we'd get x is equal to -10/3. For letter C, we're going to distribute. The only difference here is that it's an inequality. So the way we talked about solving inequalities is the same as solving equations. But if you divide by a negative, you also have to switch the inequality. So we'll subtract 2x on both sides, subtract the 15 on the other side, and we get -7x is less than or equal to -16. And we want to get rid of the -7, but we are multiplying here by it. So if we divide both sides by -7, we get x is greater than or equal to 16/7. We also talked about in class, this is written in what's called set notation, but you really shouldn't leave your answer like that. We talked about interval notation. So if we were going to graph this, we'd put a point at 16/7, and then a bracket and say anything larger than that. So the way I would prefer that you write this on the exam, I'll have to take off points if you don't, is you would just say from 16/7 to positive infinity. That's how we write the solution to inequalities. And then for this fourth problem, we want to solve for y. So we'll just have to do some manipulation here. Subtract the 2x on both sides. -3y is equal to -2x plus 6. Solve means isolate. So if we're going to get the y by itself, we could divide everything by -3. And y would equal -2x plus 6 over -3. That's good enough for me. If you want, you could also divide each term by -3. So 2/3 x minus 2. Either one of these is fine. You'll get full credit if you do either. To get that second one, what I did is I just did 6 divided by -3, and I got -2. For problem number 2, we're talking about 3 consecutive numbers that add up to 75. And when we did this in class, we said we don't know what the first number is, so we could use x for that. But then the next consecutive number, to go from one number to the next consecutive, we always add 1 to it. So the first plus the second plus the third is equal to 75. And then converting this to math, if the first number is x, the next one would be x plus 1. And then the third would be x plus 2. Combining like terms, we get 3x plus 3. And then just like before, we have to solve for x. 3x is equal to 72. And if you divide by 3, 72 divided by 3 is 24. And remember, x was the first number. I asked you for the 3 numbers. So that would give us 24, 25, and 26. If you type them into your calculator and added them, you would get 75. This next word problem, it says a 34-foot piece of rope is cut into 3 segments. The first segment is 3 times as long as the second. The second is 1 inch longer than the third. Find the length of the pieces. Well, we know that the whole rope is 34 inches or 34 feet long. And we want to try to use the same units here. So let's write it like this. We have 3 pieces in a rope. And the whole rope is 34 feet. And that's what we get by adding up each of these pieces. The first segment is 3 times as long as the second. Well, I have no idea how long the second is, but 3 times as long as that would be 3x. The second is 1 inch longer than the third. So if the second is 5 inches long, what would the third segment be? 1 inch longer than the third. This piece is 1 inch bigger than this piece. So if this was 5, this would be 4, right? So whatever x is, you would subtract 1 from it to get that third piece. It's a little tricky. But now what we have is we have all 3 of these pieces that when we add them up, that's going to equal 34 feet. So we have inches and we have feet in the same problem. Let's just convert everything to inches to make our life a little bit easier. So we'll do 34 times 12, and that's 408 inches. So 3x plus x is 5x minus 1 is equal to 408. Add the 1. And then divide by 5. 409 divided by 5 is 81.8. And that's how long our second piece is. This is 81.8 inches. And then the third piece would be 80.8. And then the first piece would be 3 times 81.8, which comes out to be 245.4. So that's how you would figure it out. We're talking in English, converting it to math, and then reconciling the two. We saw a problem like number 4 in class. It says the cost to build tables is given by this equation. Find the number of tables that could be built with a budget of $3,200. Well, cost is y, and we want that cost to be our budget, which is $3,200. So the way that we would finish this is subtract 850 on both sides to get x by itself. 3200 minus 850 is 2350. And then we have to divide by 35. And 2350 divided by 35 is 67.1. Now, I don't know about you, but I don't want 0.1 of a chair. I'm not sure what I'm going to do with that. So let's round it down and say that we can get 67 tables. All right, moving down to the graphs. State the x and y intercepts. Well, the way that we talked about getting the x-intercepts, we're making y equal to 0. The y-intercepts, we make x equal to 0. So each of these problems, let's just set ourselves up for success here. And we are going to come up with an x-intercept and a y-intercept for each of these. Now, some of these problems might not have an x or a y-intercept, but at least our work should confirm that. All right. So for this first line, x is equal to -3 is right here. Everywhere along that line, x is -3. Right? So we know that when x is equal to a number, it's a vertical line. To get the x-intercept, you put 0 in for y. There is no y. So the x-intercept would just be -3. To get the y-intercept, you put 0 in for x. But 0 equals -3 doesn't make any sense. So there's no y-intercept. And if you look at the graph, obviously there's no y-intercept. Everything makes sense. Y equals 4 is right here. Doesn't look like there's an x-intercept either. And even if you put 0 in for y, just like we talked about, there is no x-intercept. The y-intercept is clearly 4. For letter C, to get the x-intercept, we put 0 in for y. So 0 is equal to -2/3 x plus 3. Bring the 3 over to get the x by itself. And we're going to divide by -2/3. -3 divided by -2/3, we have to multiply by the reciprocal. And we get -3 times 3 over 2 is 9 over 2. 9 divided by 2 is 4.5, which is right here. Question? Yeah, so the question was, can you also just graph the equation and then find the intercepts? The problem with that is, I believe he's talking about if you start, because this is in slope-intercept form, is if you start at 3, I mean, okay, cool, the y-intercept is 3. And then what you do is you go down 2 and over 3. I did that pretty neat, right? It's pretty straight, but it looks like the x-intercept here is 5. So I would always recommend to get the intercepts, you do the rules that we talked about and put 0 in for x for y and 0 in for y to get x. Does that make sense? All right. I mean, it's close, but that's the problem when you have decimals. The x-intercept for D, we're going to put 0 in for y, and -4x is equal to -12. So x would be 3. The y-intercept, you put 0 in for x. 3y is -12. So y would be -4. Pretty straightforward. For problem number 6a, in order to figure out if the lines are parallel, perpendicular, or neither, what we have to do is go ahead and find their slopes. So the first equation, just going to make everything nice and organized. We'll do it separately. This first equation, the slope's -1/2. It's already in slope-intercept form. The slope is -1/2. Now the second equation we have to do a little bit of work on. We have to get the y by itself. So I'll bring the 2x over and then divide everything by -1. Y would just be 2x minus 3. So the slope here is 2, or 2 over 1. The other slope is -1/2. That's the definition of perpendicular lines. We have opposite reciprocal slopes. For the second problem, we'll do the same thing. We'll get y by itself. So 6x plus 4y is equal to 12. -3x plus 2y is equal to 36. Get the y by itself. So bring the 6x over and divide by 4. Y would be -3 over 2x plus 3. Here's your slope. We'll do the same thing with that second equation. We'll bring the 3x on the other side, so 2y is equal to 3x plus 36, divide by 2, and y would equal 3/2 x plus 18. Well, they're definitely not opposite reciprocal, and they're not the same thing, so we're just going to say that this is neither. It's not parallel, and it's not perpendicular. Close doesn't cut it for this. It has to be both opposite and reciprocal. For problem number 7, I asked you to write a slope-intercept form of a line with a slope of 1/2 and a y-intercept of 0, -2. So this one's pretty simple. I hope everyone gets this one right. Y is equal to mx plus b, and we just plug in the numbers that I told you. 1/2 goes in for the slope, and -2 goes in for b. For number 8, in order to write an equation of a line, we need a slope. The first one I gave it to you. Looks like for this one, I'm going to make you do a little more work. 4 minus -3 divided by -1 minus -2 gives us 7 over 1. So the slope of this line is 7. We also need a point. I gave you 2, so it doesn't matter which one we pick. I'm just going to go with the point -2, -3 because I saw it first. And then the way we talked about writing equations of lines from this is we say y is equal to mx plus b. The slope is 7. The y value is -3. The x value is -2. So we get -3 is equal to -14 plus b, or b would equal 11. If I asked you for slope-intercept, you'd be done at this point, 7x plus 11. But I did ask you for standard form. Standard form, the x and the y's have to be together, so we'll bring the 7x over. There's no fractions or decimals. And we also talked about the leading coefficient has to be positive. And what we're going to have to do here is multiply everything by -1. to get 7x minus y is equal to negative 11. All right, so this one is a little more work than some of the others. For number 9, I just want slope-intercept form. And I asked you to make it parallel to this equation. So the equation has a slope of 1/3, meaning the parallel slope would also be 1/3. And then I gave you a point of 2, -3. So this one's one less step than the last one we did. We don't have to convert this to standard form. We can go ahead and put -3 in for y, 1/3 in for our slope, 2 in for the x value. 1/3 times 2 is 2/3. We want to get b by itself, so we'll subtract 2/3 on both sides. And you could either do that on your calculator, or if you remember with fractions, we have to get common denominators. So -3 is the same thing as -9/3. -9/3 minus 2/3 is -11/3. So now we're just going to finish by writing y is equal to the slope times x, and then the b value. Okay. If I did ask for this in standard form, you'd bring the x over, multiply everything by 3 to get rid of our denominators. And then you also want to make sure that x is positive. So if it's not positive, you multiply by -1. Then the last problem, I asked you for a slope-intercept form. So y is equal to mx plus b. It has to be perpendicular to this line in standard form. So the only way we could figure out the slope is to put it in slope-intercept form. I'll subtract 4x on both sides. Divide by -5. Y would be 4/5 x minus 4. So the slope of this line is 4/5. The parallel slope would be 4/5. The perpendicular slope would be -5/4. So just make sure you're careful, right? There's a problem I ask you for parallel. You wouldn't change the slope, and obviously perpendicular, we have to change it. So we're going to do the slope of -5/4 and the point of 2, -3. If we plug in -3 for y and a slope of -5/4, we just have to multiply and put it back into slope-intercept form. So this would be -5/2, or -10/4 reduces to -5/2. We'll add 5/2 to the other side. So -3 is the same thing as -6/2. -6/2 plus 5/2 is -1/2. And then tying this all together, just make sure you choose the right slope here. The perpendicular slope was -5/4. And then we put x minus 1/2.